Hi, welcome to another lecture on business mathematics. Today we are going to talk about present value versus future value. This is essentially a renaming of a topic we talked about last time. We are just changing the name of the variables or playing with them in new context. So you remember last time we said if you go to a bank and make an account like a certificate of deposit, put certain money down. It's called principal. Let's say you go put $10,000 down, and the bank say it gives you some interest, let's say 8%, and it compounds it for you 4 times a year. So it's called quarterly compounding. And then you're willing to depart with your money for, well, let's say 20 years. T is number of years, 20 years. You will be wondering how much would the bank give you at the end of all of this. So that's the accrued amount, and they are connected by this formula. What happens now that we are renaming things? The money that you put at the beginning is called present value, and the money that you collect at the end is going to be the future value. Typically we turn the problem around and we say I am targeting for a certain amount, for a certain future value. How much should I put down now to be able to meet my target in a certain amount of time? So that's going to be a rearrangement of this. But just to remind you of a type of problem we were doing last time. So suppose we solve the problem as before. Say you are willing to put $10,000 down on an account, and the rate is 8%, and it is compounded quarterly, so n is 4, and you are willing to forego your money for say 20 years. What is it that you are going to get at the end of it? Well, at the end of it you are going to get 10,000 times 1 plus 8%. We write it 8% like that. Every period you are going to get quarter of this thing, so it's going to be 2% per each each compounding period. Now there are 4 compounding periods per year, and now you have 20 years to leave this money, and then we go ahead and calculate what this thing is going to turn out to be. So we take our calculator. So what we get there is, let's rewrite this thing, is going to be 10,000, and that's 1.02 to the power of 80, and it's going to become a large amount, $46,609.57. So our money more than quadrupled. Of course, you see this kind of scenarios with extended period of time for installment purchases like mortgages and such. Typically, banks don't sign this kind of contract with you, and whatever they do is on a much shorter period. But at any rate, it's an exercise we just practiced last time, and now we are doing it again. Now let's turn this problem around. Let's say you get married, you have a kid, and then you want to put money for his or her education. So it costs quite a bit of money. So you are going to put a certain amount of money down right now. Say you have some inheritance or something, and you suspect that say in 18 years, or you have a target date. In this case, a target date is say 18 years, and you know how much, or at least you guess how much you're going to need at that time. So we're just making up some numbers. Suppose we are going to need, say, $200,000 in 18 years. And we find some institution that is willing to give us a rate of, what's a good number? It's hard to come up with a number, but let's say 12%. very optimistic here. Nobody gives us 12%, but let's say that money is going to be compounded monthly, let's say. So with this information, the question is, what's the money that you are going to put down now? Well, that money is going to be present value of an amount that in the future is going to be worth $200,000. So this is going to be called present value, PV for present value. Notice that the notation is a bit different from mathematical notation. You have to be careful not to read this as P times V. It's just present value. It would be good to have some sort of a notation that indicates it's just one item, present value. Well, all that does is that we are going to take this formula. We want to calculate P out of it. So I have to take A and divide by this factor. So we just take the formula that we had, turn it around, and we write it like this: A divided by 1 plus R over N to the power of NT. Now if you want to rename things, this is going to be present value, and this is going to be the future value, and divided by 1 plus R over N to the power of NT. So present value, we are putting one lump sum into this account, wait for 18 years, so our kid can have that much money available 18 years from now. So that's future value is $200,000, and 200,000. Well, I made it cheap, 200,000, and then 1 plus interest rate is 12%, which we write like that, divided by 12 because of monthly. So this means monthly compounding. And the power of 12 times 18. Well, we definitely need our calculator for these strange numbers. Let's see what we get. So I enter the numbers on the calculator and I get $23,313.81. Notice the big difference. We want 200,000. How about if you put 23 now, 23,000, we are going to reach that. Of course, everything depends on finding somebody who gives us such a interest rate. You notice that no bank is going to give you that kind of interest right now, and you probably need to find other kind of investment activities to reach such a goal, but it's just an example. Here's a similar problem from your textbook with similar ideas. State College predicts that in 18 years it will take $150,000 to attend the college for 4 years. Amber has a substantial amount of cash and wishes to save money for her newborn child's college fund. How much should Amber put aside? Assuming that we have an APR of 4%. APR is just that interest rate, compounded monthly. So in this case, compounded monthly, in order to have that much money in 18 years. So 4% is a lot less lucrative than 12, but you can go ahead and do this problem in exactly same style. Sometimes when the interest rates are high, the banks advertise two types of numbers for the rate. One of them is called just rate, and the other one is the yield. To attract more customer, they want to put bigger numbers up front on their advertisement and such. So there's a concept of yield. The concept of yield is also how much would a dollar produce at the end of the year. A concept of year, you take a dollar You take the nominal interest rate, divide by the number of compounding that you're going to do, and you just do compounding for 1 year. So your T is 1. So that becomes the yield that they advertise, as opposed to the simple interest, as opposed to the nominal interest that we have here. In case they advertise continuous compounding, that's going to be exponential of R, and now we have to take the dollar that we put in out of this picture. So in this formula I have to subtract 1 from it, and this one also subtract 1 from that one. Let's see how would yield turns out to be. So suppose that we have as my previous example, say R is 12% and N is also 12. What's the effective yield? That effective yield in this case, it simply means that we put $1 down, we have a rate of 12%, but we have to divide it by 12 to get the value for each month, and raise this thing also to the power of 12, and out comes, so it's going to be 1 point, well, we have to subtract 1 from it, so that's going to be 1.01, 1.01 to power of 12 minus 1. What would that be? So we go on our calculator and we calculate 1.01 to the power of 12 and subtract 1 from it, and I get 0.1268. So if we were to advertise this thing, we would say the yield is 12.68%, sometimes called as effective interest rate. That becomes that amount. And if we were to do continuous compounding, if I do continuous compounding, I'll have exponential of 0.12 minus 1, and if I calculate that, I'll get 0.1275 or 12.75%. So smidgen more than the other one. If we do more compounding, we get more out of that. Okay, so here are 2 formulas adding to the list of the formulas that we had, but otherwise the concepts are the same as before. So in the next lecture, we are going to look at a situation where you are not putting a lump sum into the account. Rather, you are going to put money little by little. Like at the end of each month, you put a certain amount into an account. However, at the beginning, your contract asks for a fixed interest rate. So interest rate is fixed. However, you might be putting your money little by little. That case is referred to as annuity, and we are going to talk about that in the next lecture. Until then, good luck and God bless.